How many ways I can do this problem? I have caffeinated coffee here, people. The 45 and the 30 here are just big triggers for me that this is two special right triangles. This is the 30-degree angle. This is not drawn to scale. Here is the 10. They actually share this side right here. This is the side of the square right here. Here's my 45. The 30, 60, 90. This is a 60 up here. The shortest side is across from the 30-degree angle, and that's usually like an X. And then the hypotenuse would be 2 times that number. And then this side would be X times the square root of 3, and that would be my little x. Well, since it gave me the 10, then I know that this must equal 5. And since they share this side equals 5 too. All right, then we switch over to the 45, 45, 90. Again, really badly drawn, but these sides are supposed to be the same length. So this would be 5. This would also be 5. That's an isosceles. And then the hypotenuse is 5 root 2. Okay, so that's my side length. So to find the area, I'm just going to take 5 root 2 times the other 5 root 2, because they're all going to be 5 root 2. And we're going to get 25. 5 times 5. Root 2 times root 2 is 2. And we are getting 50. One done. All right, now I got to do it again, but I got to do it a different way. Well, I'm still going to start the same way, because the second most obvious thing coming to mind is to use trigonometry. I'm going to use my right triangle trigonometry, so katoa. So if you are starting here from the 30-degree angle, this x is your opposite side, and the 10 is your hypotenuse. So that would be sine. So the sine 30 degrees equals opposite over hypotenuse, x over 10. That means x equals 10 times the sine of 30 degrees. I'm not going to figure that out. I'm going to do something you probably didn't expect. I'm going to do the same thing with the 45-degree angle. It is still sine. This is the opposite, and this is the hypotenuse. X over, I don't know what that is. Let's call it S. Side. That means x equals the side times the sine of 45 degrees. Rethinking that s for the variable, but go with me, sine 45 degrees. Well, here's the thing. X equals both of these. So that means they have to equal each other. Look at me just being all twisty. You probably thought I was just going to find that number and then keep going. Yeah, when I teach, I do that. But when I make YouTube videos for my own enjoyment, it's like, I'm going to do it different, because look what I can do now. I just need to know the side length. I'm actually trying to solve for that. So I can now divide both sides by the sine of 45 degrees. And then that's going to cross off. And go to the calculator now. I went a little extra on the digits. What is that when you square it? Yeah, you're not going to trust me if I tell you it's 50, are you? Let's pull it up here. I'm regretting all the digits. Square that. 50. That is another successful solution. Okay, we're going with law of sines. So to use the law of sines, you don't need to drop the perpendicular, because you use the law of sines when you don't have a right triangle. The sine of 45 degrees over its opposite side equals the sine of 30 degrees over s. Then you cross multiply. You end up doing the same move again. So I don't need to redo that. I mean, we just did it. Like right there. There it is, the 7.07107. So s squared is going to equal 50. 4. Do I have a 4? Oh, I forgot. Oh my God, I actually did a video on this before too. Oh, I doubt you know this. Yeah, this will blow your mind. There is a way to find the area of a square if the only thing you know is the diagonal. So we have this diagonal. Since this is 45 degrees and that's 90, and this is a square, I know that's my diagonal right here. This is also 45 degrees, so I've got another right angle right here. So this is basically straight up and down. And a couple times now, at least one, we did drop the perpendicular right here. And we calculated that this length was 5. The diagonal going the other direction, this way, makes a point C. I'll put it right here. So I know that this is also 5, which means this height is also 5 because this is a square and those diagonals bisect each other. Okay, so here's the super obscure area formula for a square that I literally never taught in my whole entire life and only learned it after I retired. Diagonal, and you square it and you divide it by 2. No, shock. So now that you know that the diagonal is 10, to find the area, all we have to do is 10 squared and divide it by 2. 4. 5. Can I do a fifth one? You know what? I totally can. I just don't want to. It would be putting it on a coordinate grid and assigning points to all this stuff. And I'm like, I don't want to do that. That sucks. If you want to know where this comes from, check out this video.